So uh, let's go for Newton's law of motion. Actually, I have introduced this topic only in this year into our teaching mainly because I have seen the question from the last 2 years, and the mainly classical mechanics is now 40% tilted towards graduation and 60% tilted towards a master's level. So why Newton's law of motion is very important, and this two question was asked also into last year exam. Okay, and that means what exam held in June 8. Okay, so it is very important, and in the first time I have taken Newton's law of motion for the net student also. Obviously, it was the for JAM students. It was earlier in the course, but for the net examination, it was we have introduced first time. So now this time I am going to introduce one more topic in the Newton's law of motion. That topic will be separately taken by Mukaddar sir. That is small oscillation and basically damped oscillation and forced oscillation in a differential equation form. Okay, so this thing we have included into this time in our course curriculum because it's my internal intuition that this time question will be surely come from either damped oscillation or forced oscillation. So, and it is also very important for your JEST and TIFR exam also. Okay, so that thing will be taken separately by Mukaddar sir. And but let me first give you what is meaning of Newton's law of motion for me, and which point we have to focus on, and then we will go for a complete explanation, complete discussion, as well as problem solving session. Okay. So I have divided this Newton's law of motion into mainly three parts. The first part is all about equation of motion. If I am talking about equation of motion, I am just talking about second order differential equation F is equal to ma in one dimension only. But in this equation of motion, this time we will also introduce. So in this equation of motion, we will discuss free particle. We will discuss particle with constant force. And then we will also have resistive force. Means force is proportional to velocity. Then what will happen? And then we have a small oscillation. Or harmonic oscillator. Then we will have damped oscillation. And force oscillation. So these thing, I will also discuss this thing, but in a very brief manner. But this thing is discussed by Mukaddar sir separately in very detailed manner. Okay, how energy will change and how it is going to decay in a damped oscillation. What is forced oscillation? The completeness thing will be given by Mukaddar sir. So this is my equation of motion. So you can say this is A part. Okay, so you can expect at least one question from there in this examination. It's surely there will be one question in this part. How this question will come, that is different issue. It may be come into your statistical mechanics, it may be come into your mechanics, it may be come into your another way, but one question will be surely from this particular part. The second part is your +2 revision. Okay, this thing will be Newton's 3 law. and application in one dimension. In 1D. But for the examination point of view, there are very few questions from this section because it is just a revision of +2. But why we are doing this particular thing? Because if you will not do this thing, then next part you cannot completely solve. So I have to go into this part, Newton's law in polar coordinate. Or law in polar coordinate. Hence, I have to solve my problem into polar coordinate. When your motion is confined into two-dimensional plane, then you have to use polar coordinate and you have to solve the thing from polar coordinate. And you will be surprised that from last 2 and 3 years, every year one question is coming into the examination from this only. So only from these 3 sections, you can expect 2 questions, at least 2 questions on CSIR net, 3 to 4 questions, 3 questions, at least 3 questions from IIT-JAM, at least 1 or 2 questions from JEST examination. So this thing will be very important for your exam. Obviously, this part have very rare chance to come, but obviously you can expect this question in TIFR and JEST examination from this section also. Because in TIFR and JEST examination, you can always find that a question can come from your +2 level, whatever we have done in our +2, that friction and all different type of forces, how you can apply this thing. So there may be some question from there also, but you can expect 1 question from here and 1 question from here in each and every examination. Don't worry. Okay, so let's try to discussion of this thing. So if you want to go for any book, then the best book for your examination, IIT-JAM examination, CSIR net examination, and JEST and TIFR examination. For this part, you can straightforward go to Kleppner. That is one of the best book you can ever have. But don't worry, whatever we will discuss in the class, that is more than enough. And PYQs, if you will solve, and after then you will go for test, that is more than enough. Okay.
Can you please tell the name of the book once again?
Kleppner. I will send you the exact name and all the thing in your group. Okay. Don't worry.
Yes, sir.
Okay. Kleppner is very famous book. I think everybody know that thing, isn't it? Nahi kya?
Yes, sir.
है ना? So that is one of the beautiful book for mechanics. Okay. But this thing is not very detailed discuss into that. Actually very theoretical, that thing. But this thing is very nicely given in Kleppner. Okay. And this thing is actually included by myself in our course curriculum. Okay. Just watching the previous year questions and all this thing, I just make new chapter for you. Okay. So let's try to go for all about the equation of motion. Okay. This is very simple, very straightforward, but yes, you have to start from scratch such that you can analyze the thing, you can develop your methodology to solve the problem. Okay. So let's try to go for this thing. यहाँ तक clear है ना? Everyone?
Yes, sir.
Okay, great. तो इन सबको मैं कंबाइंड रूप से न्यूटन्स लॉ ऑफ मोशन कहता हूं। हालांकि अगर पूरी की पूरी क्लासिकल मैकेनिक्स देखो तो आप पूरी की पूरी क्लासिकल मैकेनिक्स ही न्यूटन्स लॉ ऑफ मोशन है। इवन यू विल सॉल्व लैग्रेंजियन हैमिल्टोनियन, यू विल सॉल्व एक्चुअली न्यूटन्स लॉ ऑफ मोशन फाइनली, है ना? बट यस, ऑब्वियसली एग्जाम, और मैं इस तरह आपके लिए इसलिए करता हूं ताकि आपको ये पता रहे कि किस बिट का क्या वेटेज है एग्जाम में और उसे कितना तक तैयार करना है। सो हर एक चैप्टर के पहले हम उसकी पूरी डिटेलिंग कर लेते हैं ताकि रिवीजन में आपको आसानी हो, और जब एग्जाम में प्रॉब्लम आए तो आप उसको बहुत ही फोकस वे में पिक कर सकते हो कि अरे ये तो उस पार्ट का प्रॉब्लम है। ओके, एनीवे, सो इट्स ऑल अबाउट योर सिलेबस फ्रॉम द न्यूटन्स लॉ. Let's try to go for a very interesting discussion all about we will include graph, we will include all different type of discussion, examples, all these things, such that your subjectivity about the topic will increase. Okay, So this is very important. By the way, if I will ask anyone that what do you mean by equation of motion? What do you mean by equation of motion? Anyone?
Trajectory.
Sorry?
Trajectory of particle.
Equation of motion, okay. Trajectory of a particle, good. Okay.
Time evolution of a system.
Time evolution of a,
Of a system.
what do you mean by
Of a-
system? Time evolution
of
of
a
system.
system.
Mathematically, how can explain it? Listen. First of all, we have to always try to give our examples, try to give our definition from the point of view of application. Isn't it, Sam? कि एप्लीकेशन के पॉइंट ऑफ व्यू से आप कैसे बातें करते हो, ये बहुत इंपॉर्टेंट है. Okay, and more or less we have to always keep in mind that we have to solve the problem. So from the solving the problem and from that point of view, what is meaning of equation of motion? I just don't want a bookish definition. I want just some practical definition. What do you know about equation of motion? Anyone?
Sir, an equation that can tell us where a particle will be?
Sir, it's a mathematical description of particles' motion.
Very good, but that is in English. Where is mathematics?
पोजीशन और टाइम का रिलेशन रहता है कोई भी पार्टिकल के मोशन.
Position and time का relation is the final outcome. ये तो हम देखना ही देखना है. Isn't it? If someone will tell you this is equation of motion, which thing will come first in your mind?
The combination of
Trajectory.
parameters.
Combination of parameters. Parameters are always independent.
So trajectory. Trajectory.
No, trajectory is just same thing that x versus t is the trajectory. From where you are getting that trajectory? Where is the core of that particular thing?
Force.
न्यूटन्स लॉ ऑफ फोर्स.
Newton's law, and that
How the
Newton's
particle
law
is
is
with
no, चलो ठीक है, अब मुझे बोलने दो. Actually, what we want to do, we want to find the relation between position, वन डायमेंशन में है तो इसको मैं x की तरह ही बात करूंगा. पोजीशन, वेलोसिटी मींस x डॉट के बारे में बात करूंगा, एंड एक्सेलरेशन. Look at how beautiful the relations of not find the relationship between position, velocity, and acceleration. And that is x double dot. In general, if we are talking about mechanics, these three things are very important. So how you will get the relationship between position, velocity, and acceleration? This thing is connected by equation of motion, and that equation of motion, the relationship between position, velocity, and acceleration is connected by equation of motion that is actually second order differential equation. Isn't it? That is actually second order differential equation formed by Newton's law, actually. Formed by Newton's law, F is equal to ma. So if you will write this particular F is equal to, और आपको पता है, ये सारा चीज आपको पता है, F is equal to ma. मैं वेक्टर साइन नहीं लगा रहा हूं because we are talking about one dimension. So one dimension is well known that you have only positive direction as well as negative direction. That will depends on position and its direction. And if we are going to write this particular thing, this F may be function of position, it may be function of velocity, and that value is equal to m d square x upon, and it may be function of time. And this is nothing but the second order differential equation. And obviously, if you are getting the second order differential equation, if you are going to form the second order differential equation, what you want the complete solution. So if you want complete solution, what you need? You need for the complete solution. यहाँ लिख रहा हूं, है ना? So for complete solution, what is the meaning of complete solution? I need x as a function of t and x dot as a function of x dot t. If somehow we can solve this particular differential equation, and then our purpose is that we have to find position as a function of time and velocity as a function of time. Once we will get this thing, then we find the all basic property of a system. Because all basic property of a system can be derived by the position and velocity. In general, I am talking about the mechanical property. I am not going in the symmetry of isospin and all this high energy physics symmetry. I am just talking about the mechanics where Newton's law is going to hold. Then you can discuss and analyze each and everything. Please mind it, it's a very interesting point. And this definition is given by Landau. Look at, आपको हमेशा अच्छी बुक पढ़ने की आदत होनी चाहिए. Look at, हमें पता है सारा चीज, but look at how he briefly introduced this particular thing, this particular definition from the application point of view. So somehow if you are going to write the relationship between position, velocity and time, and you can make the second order differential equation with some law, it is very important. You cannot write it with an arbitrary equation. This is governed by the one of the beautiful law that is known as what? Newton's law. And once you are writing this particular thing, you will solve this particular thing, and then you will get the complete solution. And getting the complete solution, what you need? You need two initial conditions. In general, one for x and another for x dot. Wow. So you need some initial condition. And once you know initial condition, you can solve it with your mathematical acumen, and then you can discuss the system. उसकी एनालिसिस तो बाद में होगी, बट वो एनालिसिस करने के पहले आपको क्या चाहिए? आपको ये चाहिए कि आपकी पोजीशन कैसे टाइम के साथ चेंज हो रही है, आपकी वेलोसिटी कैसे टाइम के साथ चेंज हो रही है. This is very, very important thing. Everyone is going to convince this thing, or you want to add something? Please, this is just a warm-up class, okay? This is just a warm-up class. But ये क्लास का इतना ज्यादा वैल्यू होगा कि आप फ्यूचर में जो भी प्रॉब्लम करोगे, जैसे इक्वेशन ऑफ मोशन देखोगे, आपके दिमाग में तुरंत यही चीज आएगा. Either you will solve the Lagrange's equation of motion, or you will solve the Hamiltonian equation of motion, or you will solve the any another method to solve the equation of motion. You will get exactly this thing. Everyone is comfortable with this definition? Not my definition. Actually, I have taken it from the Landau. Okay. Good. So let's try to apply all this fact, whatever we have discussed. And listen, this is the complete theory of equation of motion. Now, अब अगला काम हमारा है कि how we can solve the differential equation, और उसको हम कैसे analyze कर सकते हैं. Okay, so let's try to go for first the simplest system, and that simplest system is nothing but what? Free particle. Okay, because we will start with the no force, है ना? We will start with no force, and then we will add some different type of forces, and we will see what is going to happen all our system. और आप जब ये कहते हो कि हम सिस्टम को एनालाइज कर रहे हैं, तो सिस्टम के आप कुछ ना कुछ फिजिकल क्वांटिटीज को एनालाइज करते हो, इजंट इट श्याम? आप सिस्टम की एनर्जी एनालाइज करते हो, आप सिस्टम की मोमेंटम एनालाइज कर सकते हो, आप सिस्टम की एंगुलर मोमेंटम एनालाइज कर सकते हो. आर यू गेटिंग माय पॉइंट? ऑल दीज फिजिकल क्वांटिटीज कैन बी रिप्रेजेंट हेलो
Yes, sir.
Yes, sir.
सब ठीक है ना? एक वीडियो गायब क्यों हो गया? आई डोंट नो.
वीडियो स्टक हो गई.
Yes, sir.
और फिर आ गया. व्हाट हैपेंड?
Yes, sir. Video and audio is perfect, sir.
नाउ ओके.
नाउ इट्स ओके ना?
Yes,
हाँ.
sir.
Yes, sir.
Okay.
Okay now.
sir.
सडनली मेरा पूरा कंप्यूटर ऑफ हो गया था एक्चुअली. एंड ओके, एनीवे we will sort it. Now its recording is also okay. Okay, I think there was some internet problem for just for a fraction of second, maybe for that. Anyway, so let's try to go for first free particle. Okay, this is the simplest one.
Not come.
Sorry, hello. So first is free particle. If you are talking about free particle, what is meaning of that? Meaning of that, the force you can assume 0. There is not any force. ऐसा भी सिस्टम होता है जहां कोई भी फोर्स नहीं लग रहा है, but that is dynamical system. That is moving, है ना, with a constant momentum. So here the force is equal to
वीडियो स्टक हो गया था बीच में.
hello.
Yes.
Yes, sir.
Sir.
Yes, sir.
Now, okay, sir.
Sir,
Hello,
जैसे
मेरी आवाज आ रही है?
हाँ, sir.
Yes, sir. Now
जैसे
everything
ही
is
आपने फ्री पार्टिकल लिखा वैसे ही वीडियो स्टक हो गया था.
स्टक वीडियो स्टॉप हो गया था.
Yes,
Yes,
sir.
sir.
The moment you wrote
अभी भी
free particle,
Hmm.
video
Stop
got
हो
stuck
गया,
and
sir.
stopped, sir.
Okay, I think there is some internet issue. Let me check. एक बार मैं चेक कर लूं.
थोड़ा.
ऐसा तो कभी नहीं होता है. हाँ, इंटरनेट तो चल रहा है. एनीवे, अभी तो ठीक है ना? हेलो.
Now, okay, sir.
में रुक रहा है.
हाँ,
अब
sir.
ठीक है सर, अब ठीक है.
अब ठीक है, sir.
क्या है यार? ओके, सो मैंने फ्री पार्टिकल लिखा तो सारा रुक गया था. ओके, सो दिस इज फ्री पार्टिकल. व्हाट इज मीनिंग ऑफ दैट? योर फोर्स इज 0. ओके, एंड if your force is 0, you have m dv upon dt is equal to 0, or you can write in this form also, m dx dot upon dt must be equal to 0. So from there you can have x dot is equal to some constant c1. So this is your c1, and from here you have x as c1t plus c2. So this is if you are going to plot x dot versus t, the thing will be constant. It is not going to change with the time. But at the same time, if you are going to plot x versus t, you have a straight line, and this straight line will have slope of c1. That is nothing but the velocity, isn't it? The speed is c1, and you are just going to discuss this slope. Why I am discussing this thing, we will discuss it later, but just keep in mind that this is my x dot and this is my x for a free particle. Because if we will include the some resistive force, something like that is proportional to velocity, you will see that thing will be change, but the relationship between x and x dot will remain same. So this is very important. Anyway, let me go for a next level, and then we will introduce that particular thing also. So this is your free particle. If you want to talk about free particle, that means the position is linearly vary with the time. So for any system, if your position is linearly vary with the time, that is your free particle. आप बिलीव नहीं करोगे, एक बार एक लैग्रेंजियन का क्वेश्चन आया था, and that Lagrangian was a little bit very heavy Lagrangian, long Lagrangian. Couple term was also there. But once we will solve this particular completely, what we get? We get position as a time as a straight line. That means even if that Lagrangian was very complicated one, the final outcome is that means that Lagrangian is equivalent to your free particle. So whenever you are talking about free particle, that means there is not any force is going to act on that particular particle. The position must be vary with the time, and that should be linear in nature with a constant this particular angle. Okay, the constant slope, and this is given by c1. Let's try to go for our next one, that is, and can you give me some example of the free particle? Some example in a free particle?
Ideal gas. Ideal gas.
Ideal gas. मैं single particle system की बात कर रहा हूँ. Okay, ideal gas is free particle. Yes, there is not any potential, not any force. Okay, that is one molecule of ideal gas. You can assume that. Okay, और भी कुछ? Anything else?
Particle in 1D box.
Particle in 1D box is the one of the beautiful example of free particle. और हम उसको quantum mechanics में लेकर जाएंगे, then we will see how complicated is that, even if it is so much trivial for the classical mechanics. Okay, okay. So next we will talk about particle with a constant force. The second thing is particle with the constant force. With the constant force. Any example you can give particle in a constant force? Any example? Very trivial, बहुत
Particle
important.
under gravity.
Particle under gravity.
Gravity.
और कोई example?
Particle in a milk and drop experiment.
Milk and drop experiment इतना complicated नहीं, एक बताओ क्या force है, क्या है?
Particle under electric field.
Constant electric field. The charged particle under constant electric field. That is one of the beautiful example. ये दोनों ही आपके एग्जाम में आ चुके हैं. With constant electric field. Okay, so let's try to see how is profile of this x versus t and x dot versus t. Okay, let's try to go for this. And then we will include some complication into this particular thing. Okay. So if I am talking about F is equal to ma, let's say we are talking about particle in a gravitational field. Suppose इसको ले लेते हैं. So if we are talking about particle in a gravitational field, you have m dx dot upon dt is equal to mg, isn't it? And you have dx dot upon dt is equal to g. और आप देखो मैं कभी भी सेकेंड ऑर्डर डिफरेंशियल इक्वेशन नहीं सॉल्व कर रहा हूं, isn't it?
Yes,
मैं
sir.
सेकेंड ऑर्डर को फर्स्ट ऑर्डर बनाकर सॉल्व कर रहा हूं, बिकॉज आई लाइक लीनियरिटी, है ना. मुझे ऑर्डर बढ़ जाता है तो बहुत ही अजीब लगता है. ठीक है. सो यू कैन सी दिस इज द वंडरफुल मेथड. व्हाट विल बी एक्स डॉट?
GT plus C1.
gt plus c1. And now you can again go for a new differential equation, dx upon dt. And what is going to happen here? gt square by 2, sorry, that value is gt plus c1. And what is going to happen? X is equal to gt square by 2 plus c1t plus c2. Isn't it? You have this kind of situation. And now when you are going to solve this particular problem, if you want to solve it completely, you have to find what is your C1 and what is your C2, then only you can solve it completely. But anyway, let's try to go for a very fundamental way that let us assume at t is equal to 0, we have x dot is equal to c, and this is your straight line, isn't it? And when you are talking about x versus t, when you are talking about x versus t, what is going to happen?
Parabolic in nature.
That is all about, suppose t is equal to 0, you have value c2, and that value is something parabolic in nature. This is your x versus t. Now let's come to the last one. Let's come to the last one. When for the free particle, look at how we can do analysis. Don't worry. For the free particle, I have x dot versus t is just a straight line with, and that is moving, that is just a constant. But when you have x versus t, that is almost same here, x dot versus t. नहीं? यहां जो x dot का प्रोफाइल है, यहां ये x का प्रोफाइल है. Isn't it?
Yes, sir.
आप जस्ट इसको दिमाग में रखे रहो. अब जैसे हम नेक्स्ट प्रॉब्लम में जाएंगे तो वहां पर इसको आपको एनालाइज करने में बहुत ही मजा आएगा. ओके? Everyone is comfortable up to this? Obviously, we know that this is cakewalk for you. But I am not only interested into this part. ये तो कोई भी कर लेगा. When we will go for the next level, then see what is going to happen. Okay? So let's try to go for our next level. और इन्हीं दोनों को हम थोड़ा आपस में कंपेयर करते हैं और चीजों को देखते हैं क्या हो पा रहा है. यहां तक कोई क्वेश्चन पूछना है? So whenever you will get this type of solution, you can put g by 2 at some c naught. So you have x is equal to c naught t square plus c1t plus c2 is there. When you have this quadratic, x is varying with the quadratic equation, that means you are talking about constant force. That is all about constant force. आप देखोगे जब मैं लैग्रेंजियन करूंगा तो 2 या 3 बार ये प्रॉब्लम आ चुके हैं. बट थिंग इज दैट वहां पर एग्जाम में बहुत फास्ट आप कर सकते हो अगर आपने जस्ट एज्यूम, जस्ट आपने देख लिया ओके दिस इज कांस्टेंट फोर्स एंड दैट द सॉल्यूशन विल बी जस्ट अ पैराबोलिक इन नेचर. So you have to always keep in mind that whenever you are working with a constant force, the position is varying with the time as a quadratic and velocity is the linear. Velocity is linear. Okay, good. Now let's try to introduce some resistive force. Linear resistive force को हम लोग introduce करते हैं. Then let's try to see what is going to happen. Some linear resistive force. Okay, and it's a very interesting. जब आप इस तरह के सिमेट्री को देखोगे तो आपको बहुत ही ज्यादा मजा आएगा. The solving of problem is not very important. Once you solve it and then how you are going to analyze, this is more than anything. Anyway, what you have a force, and there is not any real force as a function of position, but you have a force which is function of velocity. So this is free particle, and we are going to introduce some resistive force. This is V. V is nothing but what? X dot. What is going to happen? How you can solve it? So again, you have M dx dot upon dt is equal to minus V x dot. And once you will solve it, you will got dx dot upon x dot is equal to minus V upon M into T. And what we will get? We will get some logarithmic equation. We will get ln x dot is equal to minus B by M T. That is, you can solve it, that is dt plus some C1. Okay, and we have to find the value of C1. Okay, so at t is equal to 0, you have some constant velocity. So let's say t is equal to 0, x dot is equal to some v naught. That is your initial condition. Then what is your at t is equal to 0, x dot is equal to v naught. That means what is your value of C1?
ln v naught.
C1 is equal to ln v naught. And what you have? You have x dot ln x dot is equal to minus b by m t plus ln v naught. We will take it here. You can have ln x dot by some constant value v naught is equal to minus b upon m t, and from here you can get x dot is equal to v naught e to the power minus bt upon m. Are you people convinced with this? So what will happen when you are going to plot x dot versus t? When you are going to plot x dot versus t, it will be exponentially decaying with the coefficient b upon m. It will just exponentially decaying with the coefficient b upon m. It's a very interesting. Okay, let's try to go for a x versus t. And when you just want to solve this thing with for dx upon dt is equal to v naught e to the power bt upon m, then x is equal to v naught, you can go for integration minus bt upon m dt. Okay, what will be solution? क्या होगा solution? बताइए.
So v naught
minus m by b है ना, e to the power minus bt upon m plus some c1. Agreed? And we can assume at t is equal to 0. At t is equal to 0, you have x is equal to 0. You can have some this type of boundary condition. So what you have, t is equal to 0, the x is going to be 0. So what is value of c1?
So V naught M by B.
So the C1 is equal to M V naught by B. Okay. And what you will get? You will get X as. You will get X as. It's a very interesting. And that value is equal to M V naught by B. You can take common. And 1 minus e to the power minus bt upon m. देखो आ रहा है ना everyone? ठीक है, कैलकुलेशन चेक कर लिया है ना? जस्ट आप t की वैल्यू 0 पुट करो, ये 1 हो जाएगा, ये x की वैल्यू 0 हो गई, ये इधर आ गया, एंड यू कैन इजिली go for this thing. Now, when you are going to plot x versus t, what is going to happen? Wow. Look at this thing very carefully. When you will go for x versus t, what is going to happen? At t is equal to 0, you have some. You are at the origin.
0. X equal to 0.
X is equal to 0. And as your time is going to increase, isn't it?
X
What is
equal
going to
MV naught
happen?
by B.
Huh?
X equal to MV naught by B.
What will happen at t tends to infinity? You have some constant value, isn't it?
Yes, sir.
Yes,
है ना?
sir.
So what you will get? You will get something like this. Everyone is comfortable? So initially it will increase and finally it will just go on to the saturation. The thing will be stopped at some particular point, isn't it? The position will be constant and velocity will be finally going to decrease. Look at this particular thing. Now, let us try to go for the whole thing in one frame, and then I will try to ask you which type of profile will come if I will add here the constant force, let's say mg. But before that, let me revise all this thing and then we will go for a next level thing. Let's try to go for this thing. Look at this is actually magic. For the free particle, we have here we have x dot versus t is constant. X versus t, a straight line varying with the linearly varying with the time. And now we have a constant force. What we have x dot versus t is going to decrease. Okay. Sorry. X dot versus t is the linear and x versus t is something like parabolic. I'm not going for the negative t. Okay. We are doing the practical thing. Now what we have pre-particle with minus BV. What is your x dot versus t? This is going like that. What is going to happen? X versus t? This is going like that. Now my question is that, look at, we will solve it, don't worry, we will solve it. But before that, let us try to see the magic. And then we will find why this magic will, from where this magic will come into picture. Suppose I am going for a force that is F is equal to mg minus bv. Suppose this is my F is equal to mg minus bv. Can anybody expect what should be x dot versus t? What should be x dot without solving anything? We will solve it, don't worry. हम लोग इसे solve करेंगे, but आप क्या expect कर सकते हो? क्या होगा आपका आंसर?
सर दोनों के मैग्नीट्यूड पे डिपेंड करेगा ना? मैग्नीट्यूड पे डिपेंड करेगा ना?
बिल्कुल मैग्नीट्यूड, बट इन जनरल मैं पैटर्न की बात कर रहा हूँ.
First increasing linearly, then decreasing exponentially.
That means ऐसा होगा, है ना?
Yes.
पहले linearly फिर decrease करेगा. Sorry, this is wrong.
Yes sir.
This is wrong. This is wrong. This is wrong.
So firstly decreases then become constant.
पहले decrease करेगा फिर constant होगा. No, this is also not correct.
First linearly increase करेगा, उसके बाद decrease करेगा.
चलो इसको मैं आपको मैट्रिक्स के टर्म में दिखा देता हूँ. रुक जाओ. वेट. अब मैं ले रहा हूं mg माइनस bv. यहां पर मान लो मैंने mg ले लिया, ठीक है. चलो यहां मैंने लिया फ्री पार्टिकल 0 माइनस bv. फ्री पार्टिकल मींस f इज इक्वल टू 0. अब बताओ क्या मिलेगा? इसे देखो फिर यहां पर प्रिडिक्ट करने की कोशिश करो.
पहले सर इंक्रीज करेगा फिर एक्सपोनेंशियली कांस्टेंट रहेगा.
पहले मींस ऐसा ही पिक्चर होगा ना?
यस सर.
Very good. So you will see what will happen when you will go for x dot versus t. First it will going to increase and then it is going to constant. Look at, I am not going to solve this problem right now. मैं solve नहीं कर रहा हूं, मैं just आपको final answer दे रहा हूं. On the basic intuition, whatever I have solved here. Why? जैसे ही यहां पर आपने फ्री पार्टिकल से कांस्टेंट फोर्स में गए, जो यहां x का प्रॉपर्टी था वही प्रॉपर्टी यहां किसका है? ये x डॉट वर्सेस t का है. दैट इज लीनियर, है ना? यू कैन, अगर आप मैट्रिक्स को समझते हो तो आप ऐसे देख सकते हो इसको, इजंट इट? और अगर मैं सेम चीज में माइनस बीवी कर रहा हूं, यू विल सरप्राइज, this thing will be exactly same. I will solve it into next class, not today. आप देखोगे, बिकॉज एक ही दिन में कर दूंगा तो आप परेशान हो जाओगे, बिकॉज कुछ बच्चों का आज पहला दिन भी हो सकता है क्लास में. And now if you have this information, can anybody tell me what should be x versus t without solving anything?
It looks like constant force.
सोचकर बताओ, सोचकर.
Sir, parabola.
नो, सोचकर बताओ, सोचकर थोड़ा सा सोच लो. इतना फटाफट आंसर देने की जरूरत नहीं है, थोड़ा सा सोचने की कोशिश करो. टुमारो वी विल सॉल्व दिस थिंग कंप्लीटली, बट आज ही मैं आपको आंसर दे रहा हूं दिमाग लगाकर. What should be answer? Anyone?
पहले exponentially बढ़ेगा और फिर linearly बढ़ेगा.
Very good. What will happen? बाद का जो पिक्चर आप देख रहे हो, when t is very large, this is constant velocity. Look at, this is constant velocity. तो वैसा ही तो नेचर होगा आपका x वर्सेस t का at the t tends to infinity. Are you getting my point?
Yes, sir.
अरे देखो तो, इस पार्ट को छोड़ दो, इस पार्ट को देखो, इधर वाले पूरे पार्ट को आप देखो, ये दैट इज एग्जैक्टली दिस थिंग, इजंट इट?
Yes sir.
अगर वो एग्जैक्टली ये है तो इसका x तो ऐसा ही आ रहा है ना.
Yes, sir.
सो व्हाट विल हैपन, ये बाद में जब t बहुत बड़ा हो रहा है, जब ये लीनियर x डॉट कांस्टेंट हो रहा है, तो निश्चित रूप से आपका बाद में क्या होगा, दिस विल ऑलमोस्ट स्ट्रेट लाइन, बट इनिशियली इट विल गो लाइक द पैराबोलिक थिंग. It will just go exponential increasing, and after then this will be x versus t. So you can see
स्टार्टिंग को एक्सपोनेंशियली इंक्रीजिंग कैसे प्रेडिक्ट किया?
स्टार्टिंग एक्सपोनेंशियली आप नहीं भी कह सकते हो, तो आप एटलीस्ट ये तो कह ही सकते हो ना कि जो इसका इंटीग्रेशन होगा वही तो ये मिलेगा.
यस.
अरे ये
Yes.
वाला पार्ट कैसा है इसका, ये वाला पूरा का पूरा इक्वेशन तो देखो कैसा है.
सर क्लियर.
क्या आया था, समथिंग m b बाई v नॉट था ना, 1 माइनस e टू द पावर माइनस क्या था ये,
BT by
एम बी बी बाई टी, ऐसा ही तो था. कांस्टेंट टर्म क्या आया था बताओ, जस्ट टेल मी.
MV not by
M V not by B.
एम वी नॉट बाई बी, इजंट इट, यही तो है.
यस सर.
ये x डॉट का वैल्यू यही तो है. तो इसको जब इंटीग्रेट करोगे तो एक्सपोनेंशियल टर्म तो होगा ही होगा ना, इजंट इट.
यस सर.
एक्सपोनेंशियल टर्म होगा ही, और साथ में एक और टर्म आएगा, तो उन दोनों को मिलाकर के जो भी पैटर्न रहेगा, दैट पैटर्न विल बी वेरी शॉर्ट पीरियड के लिए, लेकिन बाद में क्या होगा, दैट विल बी ऑलमोस्ट स्ट्रेट लाइन, इजंट इट.
ओके सर.
सो थिंग इज दैट, लुक एट दिस पर्टिकुलर थिंग. मैंने दो बहुत ही ट्रिवियल प्रॉब्लम को सॉल्व किया, उसकी प्रॉपर्टी को देखा, उनके बीच की रिलेशनशिप को जानने की कोशिश की, एंड व्हेन वी विल ऐड सम कॉम्प्लेक्सिटी, देन ऑल्सो वी कैन एनालाइज द थिंग इन अ वेरी डीप मैनर विदाउट सॉल्विंग इक्वेशन. मैंने जस्ट एक्स डॉट को सॉल्व किया था, और वो भी मैं नहीं सॉल्व कर सकता था, वो भी बिना सॉल्व किए हुए. अगर मुझे ये इक्वेशन पता है कि इसकी इस तरह की प्रॉपर्टी है, देन ऑब्वियसली with the help of these two things we can go for this one. एक पूरी की पूरी मैट्रिक्स समझ में आ रही है, अगर मैं पिक्चर के मैट्रिक्स बना करके दूं तो?
Yes, sir.
Isn't it something like symmetric matrix, isn't it? Wow. This is diagonal term and this is off diagonal term, and these two will be exactly same. And look at here, this is something like symmetric matrix, isn't it?
Yes, sir.
Sir,
Yes.
sir, yeah, if B is negative, that is force is plus PV, then profile of x dot t is same as profile of x and t.
No. That
for-
profile will be not. Okay, what you want to say?
For f equal to plus PV.
Okay, you want to add the plus thing. Okay.
Plus PV instead of minus PV.
Then what will happen? Then what will happen? This thing will be plus. This thing will be plus.
And e to the power plus mt by b.
That is e to the power plus. So that will be just increase, and increase.
That is profile of x dot t.
X dot t
is same as xt profile of mg.
We can discuss. We can see which type of profile is going to happen. Look at here. First thing is that don't confuse with this particular only v term. Okay. Don't confuse with this thing. Why we are doing this particular thing? Because in x dot versus t, we have exactly free particle symptom. Are you getting my point? Look at here. This thing has exactly free particle symptom. Then only we can go up to this one. Are you getting my point? आप समझ रहे हो मैं जो कह रहा हूं?
Yes, sir.
मैं ये कह रहा हूं कि आप यहां पर अगर इस पूरे चिन्ह को हटा दो तो ये सिम्टम क्या है? दैट सिम्टम इज एग्जैक्टली फ्री पार्टिकल सिम्टम, इजंट इट?
Yes.
तो मैं वहां से कंपेयर कर रहा हूं चीजों को.
Okay.
Are you getting my point? I am not comparing arbitrarily.
Okay.
If I have the feeling of free particle thing, and which is there, अब more or the maximum time पर ये free particle की तरह ही behave कर रहा है, नहीं कर रहा है क्या?
Yes, sir.
Then only we can talk about this kind of thing. Or in his, and I will just check, I will not give you the just confusing answer. What will happen to plus? You can solve it and then you can see what will going to happen. At that time, I think your x and x dot will be just varying same type of thing.
Exponentially increasing.
Both will be exponentially increasing.
Okay, sir.
Okay?
Hmm.
Because listen, what is going to happen here? This is very important thing. You have weight and this thing is resistive force. Are you getting my point? So you
Yes,
have
sir.
weight and there is some air drag.
Hmm.
Okay?
Viscous force.
Maybe viscous force, maybe some air drag, some this kind of thing is going to happen. Then what will happen? When you are getting the free particle thing, that means your force will be ultimately zero.
Critical velocity.
That means what will happen? Two forces will just oppose each other, and at some particular time, these two forces can be equal, but in opposite direction. So the thing will be just behave like a free particle, and you are just saying, you are coining the very important word, that is the critical velocity. What is critical velocity? And that value we can easily find. This particular value is the critical velocity, where your particle is just going to be constant motion. That means your gravity is overcome by the viscous force. So initially the particle will have some increasing velocity, and after then it will just go like a free particle, because you have two opposite force. But in your case, when you are adding something, you are actually supporting this one, isn't it?
Yes, sir.
You are not going to oppose this one, you are going to support this one. So when you are going to support this one, what will happen? It will go very और ज्यादा velocity और ज्यादा velocity. एक force तो लग ही रहा था, तुमने और force देना शुरू कर दिया उसको.
Yes,
so
sir.
that is very trivial thing, isn't it? Non-triviality is with the minus thing. Are you getting my point? ये तो बहुत ही trivial है. एक force लग रहा है तो उस direction और force लगाओ तो क्या होगा? और तेजी से जाएगा और क्या होगा? Isn't it?
Sir.
हाँ. So actually हमें कहां पर फंसेंगे हम, वो important है ना. ये तो बहुत ही सिंपल है. अगर मैं प्लस कर दूं तो इसमें बचा क्या? कुछ भी नहीं बच रहा है. There is nothing called any balancing force or nothing this type of thing. Okay? तो एग्जाम में अगर आएगा तो ये कभी नहीं आएगा. इसका क्या पर्पस है भाई? फोर्स लगी रहा था और फोर्स दे दिया. आपको चीजों को बैलेंस करना है ना. So this type of thing will be more important. So in the next class, I will try to solve this differential equation, and then we will see this kind of thing will happen or not. And then we will go for a simple harmonic motion. We will also discuss a hyperbolic equation. ये भी एग्जाम में आ चुका है. And we can solve different type of problem. Okay? And little bit of damped oscillation. So कल मैं equation of motion को finish करूंगा, and then we will go for Newton's law. Okay?
Yes, sir.
Okay. So most probably कल आपका मैकेनिक्स का 2 क्लास होगा. एक मैं लूंगा और एक मुकद्दर से लेंगे, because he is little bit उनको थोड़ा हेल्थ उनका आज खराब है. So अगर ठीक होता है तो कल 2 क्लास मैकेनिक्स की होगी. Okay? Because he just start his damped oscillation and all this thing. So सब आप एक साथ ही कर पाओगे. Okay?
सर
हाँ बताइए.
सर वो मैट्रिक्स फॉर्म में कैसे है वो?
अरे मैट्रिक्स फॉर्म में विजुलाइज करने के लिए बोला हूँ यार.
हाँ.
क्या बात कर रहे हो?
मतलब कैसे?
अरे दादा, जो पैटर्न यहाँ मिला वही पैटर्न यहाँ मिल रहा है. मैट्रिक्स क्या है? मैट्रिक्स इज जस्ट अ रिप्रेजेंटेशन. नहीं समझ में आया? अरे दादा, नंबर ही नहीं हो सकता है. यहाँ 0, यहाँ ये भी तो एक तरह का रिप्रेजेंटेशन है, ये भी तो एक तरह का मैट्रिक्स है.
यस सर.
ये दोनों एक जैसा नहीं है? अरे हाँ या ना?
यस.
हाँ, मैं समझने के लिए बोल रहा हूं भाई. उसी तरह से इसको भी इस फॉर्म में नहीं दिखा सकते क्या?
यस सर।
दिखा सकते हो ना? तो मैं जस्ट एक बोल रहा हूं, अगर तुम विजुलाइज करो एक मैट्रिक्स को, तो आप कुछ इस तरह से चीजें पा रहे हो कि जो एक्स का पैटर्न फ्री पार्टिकल में है वही एक्स डॉट का पैटर्न कांस्टेंट फोर्स में है। सिमिलरली माइनस वी के भी ऐड करने से जो एक्स का पैटर्न फ्री पार्टिकल में है वही एक्स डॉट का पैटर्न आपका वेट के साथ भी है। ये मैं कहना चाह रहा हूं। मैंने मैट्रिक्स वर्ड यूज कर लिया क्योंकि हम लोग फिजिक्स के स्टूडेंट हैं, तो हमें मैथमेटिकल वर्ड यूज करना चाहिए। अदरवाइज यू कैन से दिस इज वन टाइप ऑफ सिमेट्री। नहीं? ओके, सो आज के लिए इतना ही रहने देते हैं, कल हम लोग इस टॉपिक को कंप्लीट करेंगे। ओके,
Okay, thank you, sir.
Thank you, sir.
थैंक यू, थैंक यू।
Thank you, sir.